Hello class, welcome to 1.3 Subtracting Whole Numbers. Our focus here would be on these objectives: to subtract whole numbers and to look at applications of subtracting whole numbers. Now we know that to subtract means to take away, right? And so the word subtraction actually is indicated by the notation, which is the minus symbol, right? This dash-like symbol. So to translate word phrases to math notation, we see that again in real-world scenario, we don't necessarily use the word subtraction in many cases. We do use other words for it as minus, difference, decreased by, less than, subtracted from, and so on. And if you look at the example, I think that is really important, because subtraction is pretty specific about the order, unlike the addition. In addition, we did not mind the order because the commutative property worked, the identity property of addition worked, but here we do not have those properties, and therefore the order matters. So it becomes even more essential to translate these word phrases correctly. So if we say under this example here, 5 minus 1, very straightforward. So you do the 5 and put the minus symbol in the place of minus, and that's how you write your expression. If we say the difference of 9 and 4, the difference is a very official math word for minus, right? Subtraction. And so if you see that difference of 9 and 4, then you keep the order as you see it, the 9 and the 4, and in the place of and, you bring in the minus symbol. So you see the 9 minus 4. Now it's for the other things that we have to be super careful. So it says decreased by. 7 decreased by 3. So 7 is decreased by 3. 7 becomes less by 3. And if you understand that, then you have 7 minus 3. On the other hand, when it says 5 less than 8, less than 8, 5 less than 8 means you have 8 and it's 5 less than that. So 8 comes first, and so you put the 8 minus 5. 5 less than 8 is 8 minus 5. Likewise, 1 subtracted from 6. So 1 subtracted from 6, meaning you had the 6 and from which you subtracted a 1, right? So if you rearrange the expression to understand the meaning, you'll see that the order has to be switched around when you write it in a mathematical expression as 6 minus 1. Now note that for subtraction as well, you're not supposed to use the calculator, so you're going to do it by hand. Just like addition, we will be arranging them vertically and then we will take the difference. Now let's take a look at this word problem here, example 1.38. A washing machine is on sale for $399. Its regular price is $588. What is the difference between the regular price and the sale price? This sounds pretty simple. So let me write that information out here. So I just clear all the clutter and just write what I see in the problem as being able to translate to a math expression. So it says the difference, what is the difference between regular price and the sale price? Now if you go back to the table where, again, when I say go back, I mean that you will have you're expected to have your ebook open when you listen to the lectures. So you're playing the lecture and you have the ebook open. So go to the ebook and go to the very page that this lecture is about. And there the page that I just saw, which showed the table of the word phrases and the mathematical expression. There, if you see, we saw that when it says difference between something and something, we keep the order. Okay. So the translation for this would be regular price minus the minus symbol, sale price. Once you're able to interpret this sentence into, you're still keeping the words as in the problem, but you have translated it into the proper order for your difference. Now you can actually go back to the problem and look at the regular price. The regular price is $588, sale price is $399. So 588 minus 399. the next step would be to actually put it vertically. Now, you know, in subtraction, in addition, we do the carrying. In subtraction, we do the borrowing, right? So when we subtract, we stand in need of values, so we borrow. So now when we first start with the arrangement, the alignment of the numbers, they're all the same way as per the place value chart. So here you had 3 and 3 digits, so they matched nicely. Now we always have to maintain the order, and so 588 minus 399 is what is given. Now 8 minus 9 is what you will do, but because 8 is smaller than 9 and it is in the ones place, you borrow a 10 from here to make it 18, because you're borrowing it from the tens place. This is the ones place, this is the tens place, right? So you borrow the 10, that's why you make the 8 into an 18. So 18 minus 9 will be a 9. Now because you borrowed a 10 from here, right, this 8 would now become a 7. Okay, now we do 7 minus 9. It's still not enough, because now you have to borrow 1 from 5. So if I borrow 1 from 5, this becomes 17, but the 5 will reduce to a 4. Now I have 17 minus 9, which is 8, okay, and 4 minus 3, which is 1. And actually, when you do all the borrowing, it is possible sometimes that, you know, you either borrow too much, in the sense, not too much, you borrow, but you do not reduce the other number after you have borrowed. Then that's a very common mistake. How do we catch such mistakes? We check it by using the addition, because subtraction is indirectly addition, right? So we have the 399 plus, so this plus the answer you got. If you would add these two, it should give you back the 588. That's what I meant by indirect addition. So we have 9 plus 9, 18, 1. So 8 plus 1, 9, 9 plus 9, 18, 1. So 3 plus 1, 4, plus 1, 5, 588. So you know that your subtraction is right. It's very important to check your answers, because with subtraction, it is something that, especially, you know, doing it by hand, you're maybe not used to it. You're so used to the calculator. And so for exam purposes and all that, I'd like to see the check by the side to know that you took the precautions that are inbuilt to make sure that your answer is right. Okay. Let's do the try it problem here. The weather forecast for June 2nd in St. Louis predicted a high temperature of 90 degrees Fahrenheit and a low temperature of 73 degrees Fahrenheit. What is the difference between the predicted high and low temperatures? Okay. So you have again that key phrase here in the second sentence, which is what we're going to pull up. Okay. The difference between the predicted high and low temperatures. So then this then would be translated as predicted high minus low. I keep the order in which so and is your big draw here, because you're trying to compare the two things, and that is how you know the order should be preserved. The left of and comes first, the right of and comes second. And then you will go back to the problem and supplement the information there. High temperature was 90 degrees and low temperature was 73 degrees. 90 degree Fahrenheit minus 73, was it? Yeah, 73 degrees Fahrenheit. And then you don't have to do those arrows, but it kind of reduces too much explanation as to what you're doing, like translate, math notation, simplifying. So minus 73. Here again you do have 0 minus 3, which is too small, so you borrow a 1. So as soon as you borrow, make a change there. So 10 minus 3 is 7. 8 minus 7 is 1. Do the check. 73 plus 17. 7 plus 3, 10. 7 plus 1, 8 plus 1, 9. 90. So that gave us back the 90, and so we got the check working. All right, so this is a very light topic. So basically, that's pretty much our lecture here for the explanation on subtracting whole numbers. All right, I will see you in the next one.